Hello, I'm going to walk you through the starting of Project 3. We're going to again look at k-means clustering. So we're going to cluster some unsupervised data, and we're going to do it with a bigger data set that we haven't looked at before. So as on previous ones, you've got to import your libraries here. And then we're going to look at this data set. We're going to use this movie lens data set. This is a large data set of movie ratings that are out here. Here's the website for it. This is a website that collects movie ratings, kind of like Netflix, because people rate movies. They have a huge data set. This is their 100K, so it has 100,000 ratings on it. This is actually one of their smaller data sets, but for our work, it's good. Their main data set is actually have 20 million ratings, but that would be too hard for us to do. So again, we're using this 100,000 rating system that's recommended for educational use. So we're going to import that here. I've got the data files set up on GitHub so you can download them. And again, they should download relatively quickly. And here's just an example of them. So every movie has a movie ID, and then the title of the movie, and then some of the genres. So that's the first thing. And we also have the ratings file, and we'll look at that in just a sec. So we're going to do a couple changes to the ratings file. By default, the ratings are 1 to 5 stars. So a good movie might be rated 4 stars, and a bad movie might be rated 2 stars. We're going to see some issues with that, so we're also going to add another rating system, an adjusted rating system that'll go from -10 to +10, and we'll talk a little bit about why we're adding that later on. But initially, we'll use this rating system here, and so we'll have a bunch of movies and a bunch of ratings. We're going to have to format that data a little differently. So, in section 1 here, we're going to convert this data into a matrix. So this is every user. There are 670 users in each movie here. And so this says user 5 rated movie 3 4 stars. So they kind of like that. Here movie 6 was rated by user 666 as 5 stars. So really liked that movie. Now you'll notice that a lot of these not a number variables in here. That's what the NaN stands for. And so we can't run k-means when we have not a number fields in here. So initially we're going to just replace those with zeros. Now this is not the best solution probably. It might cause us trouble, and we'll ask you more about this later. But initially we're just going to replace all the ratings that were in that. So a 0 just means that movie 1 was not rated by user 4. There's a 0 in there. We're also going to do a little principal component analysis. Remember, we use that to reduce the features, and right now we're doing it with 20 features. So again, the idea is that we have 670 user ratings here, and that's too many features for some of these algorithms. So we're going to reduce it to 20 components rather than 607 users. So it kind of groups users together in some ways for this. So your first task here, I had this mislabeled task 4, but it should be task 1. Your first task now is to try to use k-means here and try to do some analysis of this. How many k-means clusters should we use? Remember, with k-means clustering, you have to choose how many clusters to use and look at should you be using principal component analysis or not here. When you run this. So do you want to use principal component analysis or not? So here, right now, we set up principal component analysis, but we don't actually, movie pilot is our variable we set up with all of our movie data in it in our array there. And here we don't do principal component analysis because that line is commented out, the pound sign means it doesn't run. So if I wanted to do principal component analysis, I would do that and that would reset. But for now, I'm not going to do principal component analysis initially. So again, if you want to try principal component analysis, just remove that pound sign, that comment on that one line, and rerun that cell. And then you should do your write-up here. So here's how I have set up to do k-means analysis. Initially, we have 20 clusters set up here that we have. And again, you want to probably try different numbers of clusters, try to find a good set of clusters that will run. Now, this is a larger data set, so it is going to take a while to run some of these algorithms and work with. So this just shows how many movies are in each cluster. So this actually shows that in one of the clusters there are 4,000 movies, where in a lot of the other clusters there are under, around 100 or 200 movies. We're going to have you look at some ways to analyze the clusters. One way is you can pick a particular cluster, like cluster 4 here. And that doesn't have many movies in it in the current setup. And you can look at all these movies and see if they're similar to each other or not here. And so hopefully you'll recognize some of these movies. Although a lot of them are a little older in this, 70s, 80s, and 90s. But here, Wizard of Oz and Citizen Kane. Now, in my mind, Citizen Kane has a drama mystery, and Wizard of Oz is a children's musical. So I don't think those are really related. So I don't think this is actually doing a very good job at these clusters. So whatever clusters and whatever method we're working on right now is not doing very well. You can also do this plot. Here, though, this plot's only going to work if you've done principal component analysis above, and it will display the features above of the data and do a graphical view of it. We can also do an elbow analysis. Again, this is going to take a while. Now, we're going to look at number of clusters from 2 to 50, and we're going to do every 5 clusters. So we'll do 2, 7, 12, or whatever, because if we did every one, this would take a long time to run. Even so, this is going to take a minute or so to run. I'm going to actually pause this video until it's done. So it took well over a minute for that to run. But here's the curve. And again, you can kind of look at this and try to maybe get some ideas of what might be a good number of clusters in this elbow. Likewise, we do silhouette analysis here. And again, I'm not going to run this code because this code does take a while to run. But you can run it again there. And this will show, again, different number of clusters and how they work. So again, you can remember what we've talked about, and analyze how these clusters are looking for a different number of clusters. Now, in the silhouette analysis, you can actually change this. Right now, we're doing 5, 10, 15, 20, and 25 clusters, or at least if I ran this, that's what it would do. So again, you can change these numbers if you want and run it here, and just if you want, just specify 1 or 2. And again, there you can look at these different number of clusters and how they're set up and to run. And certainly you're going to want to watch ones where clusters are going negative, like we mentioned before. So again, try those different things all the way down to where section 2 starts, and then the write-up up here. So you want to say, how many clusters do you think you should use, and how did you determine that? Should the data should the dimensions be reduced with principal component analysis? How much should you do that? 22? What do you do? So try out some different things and see if you can describe what you tried and how the results and what you think is the best option here. And then the second part is, do you agree that this clustering is not working out well? There are some issues here. How do you think we should evaluate the clusters? What are some ways we could evaluate that? And then we go back to this discussion of the movies, and movies that are not reviewed were given a 0. And what does that mean? How do you think the algorithm is interpreting 0? If 1 is a bad rating, as 5 is a good rating, what do you think it's interpreting 0 as? So again, write that up, and then you can go down to section 2 here. And 6 and 2 is a similar process, but now we're using adjusted ratings. So again, rather than 0 for no ratings and then 1 to 5 for poor to good ratings, we're using negative values, -1, -10 for poor ratings. 0 either means a neutral rating, like a 3, or no rating, and then positive values +1 to +10 are the positive ratings here. So again, you can run the code that'll set that up and display the movie values. And again, we're going to get rid of those. But again, now we see positive and negative ratings in here. And again, you can decide if you want to do principal component analysis here. And again, if you don't, you can just not run that line or comment this one line out. In this new version, the pivot table, the data is called movie pivot adjusted. So rather than just being called movie pivot, it's called movie pivot adjusted here. And so that's why we're using it a lot here. And again, you have to analyze the movies. You can run k-means with the number of clusters you want to try. You can print out the values. You can pick a particular cluster and show which movies are in that cluster. You can do this graph, especially if you do principal component analysis, it'll show that. You can run an elbow simulation here, and you can do silhouette analysis here. So do those, and then do your analysis as part of this write-up. With adapted ratings, did the clusters change? Do you think it improved? And what do you think of these ratings, and what did you use? So likely if you found some good measurements above for the number of clusters, you might want to see if that continues to work down here also. Okay, the final thing is to talk about some improvements to this. So your last task here, and this should actually be task 3. Sorry about that. Is to look at how might we improve this clustering method. And again, I want you to just keep considering clustering. Actually, with movie rating systems, there's a whole area of what are called recommender systems. Recommender systems have kind of similar algorithms, but slightly different on analyzing recommendations from people and doing that. So what are some other methods? So right now we're clustering movies. We could also cluster users, and rather than having each movie have each user's ratings, you could actually look at each user and what movies they watched. You could do other things there. So what other methods do you think could maybe improve the clustering that we're using here? So that's your third task. You might have to do a little research and try to think of some ideas. And if you want to try some code, you can certainly try out some of these examples, some of your improvements here also. So that's the end of this challenge. Hope you enjoy it.